All right, good morning, everybody. Hope you're doing well today. So, we are going to continue our discussion on Chapter 2, Section 6, where we are talking about ratios and proportions. So, today we need to start by looking at a couple of vocabulary words. The first vocabulary word I want to talk about is rate. And the rate is the ratio of two measurements having blank units of measure. So the blank part, the ratio of two measurements having different units of measure. So this should be different. Okay. And an example of a rate would be something like miles per hour. So miles and hours are different units of measure. Um, Remember, too, the word per, when you hear per, it actually means in math class to divide. So when you have miles per hour, that is saying we took miles and we divided it by hours. Another example would be gallons per mile. That's another one where you take your gallons that you use and you divide by the number of miles that you've driven. Now, a scale is a rate used to make a scale model of something too. So a scale, an example of a scale would be if you've ever done modeling or if you've looked at a map on Google Earth, for instance. Both of those, if you look usually in the bottom right-hand corner, there will be a scale that will tell you, for instance, on a map, that 1 inch actually is the equivalent of 1 mile, or maybe 1 inch is the equivalent of 10 miles, right? So the further you zoom out on a map, the longer 1 inch would actually represent. So that is something that is also used in proportions. And so let's take a look at a couple of word problems. So it says rate examples. It takes 7 minutes for Isabella to walk around the gym track twice. At this rate, how many times can she walk around the track in half an hour? And so, when at the beginning of this first video that I made for this chapter and section, I said that ratios and proportions are one of the most useful things that I'm going to actually teach you this year. This is an example of where you can use a proportion to solve a problem. And you'll see kind of a reoccurring theme here is if you know one rate, you can extrapolate that into a different scenario where maybe you need more of something or you need less of something, or maybe something is going to take you longer to do. In this case, it says it takes 7 minutes to walk around the track twice. So that's 7, and this twice are going to be the numbers that we use for our first ratio. And the ratio is 7 minutes over 2 laps. Okay. And now we need to come up with another ratio that we're going to make proportional to our first ratio. And that second ratio says we're looking for how many times can she walk around the track. So we don't know how many laps, right? So the laps here is X, but they want to know in a half an hour, which is 30 minutes. And so what I wanted you to notice about when I set up this proportion is the proportion is set up with the same units, both in the numerator and both in the denominator. This is the most important part about when you set up a proportion before you solve it, is you have to be consistent with the units. So you can see I have minutes on top in this one, minutes are on top in this one, and I have laps on the bottom here, and laps are on the bottom here. Now, you might say, well, what if I switched them? What if I had laps on top and minutes on the bottom? You could actually do that, and it would not matter. However, the other ratio would also have to be labeled that way. So you would also have to have laps over minutes. So again, you have to be consistent with your labels or your units. So if minutes is on top in the first ratio, it's got to be on top in the second one. And so now that we have our proportions set up, this problem is very similar to what we did at the end of the first video type of problems, where you just have to cross multiply. And so that's exactly what we're going to do. We're going to multiply 7 times x first, and then we're going to do 2 times 30 like that. So we have 7 times x, and that's going to equal 2 times 30. And so you can see 7x would equal 60. And then in order to solve that, I'd simply divide by 7, and you would get x equals 60 over 7. I would rather you not write a decimal. I want you to leave it as a fraction or a mixed number. In this case, 7 will go into 60 8 times. And so 8 times 7 is 56. We're trying to get to 60. We're at 56, so the remainder is 4. So the remainder is 4, and you always put the remainder over what we originally divided by, in this case, which was 7. So you can see, and remember what this represents, this 8 and 4/7 represents how many laps she will be able to make in 30 minutes. So 4/7 is slightly over a half. So they're going to be able to do a little bit over 8.5 laps in 30 minutes. Here's another rate example. It says the gear on a bicycle is 8 to 5. That means that for every 8 turns of the pedals, the rear wheel turns 5 times. So suppose the bicycle wheel turns about 2,435 times during a trip. How many times would you have cranked the pedals during the trip? So again, we need to take the information that we have. You can see the bicycle, the gear ratio is 8 to 5, and it says the wheel turns 2,435 times, and they want to know how many times would you have to crank the pedals. So we want to be consistent with our units. Let's start with the ratio that we know. It says the gear on the bicycle is 8 over 5. Now remember, 8 turns of the pedals, so I'm going to put 8p standing for pedals, and then the wheel would turn 5 turns. So you can see 8 pedals to 5 turns of the wheel. Now from there, we're going to set that equal to another ratio because we're setting up a proportion, and the units need to be the same. Pedals on top, wheel turns on the bottom. In this case, they told us that the wheel turns about 2,435. So that's going to go right here. 2,435. And our unknown is how many times the pedals turned. So we'll call that x. So now that we have our proportion set up, we're simply going to multiply. We're going to do our cross multiplication. So we're going to start with, let's start with the easy one, which is 5 times x. And when we do that, we get 5x. Then I'm going to multiply the 8 times 2,435. So 8 times 2,435 is 19,480. And then from there, it's a simple one-step equation where we divide by 5 on both sides, and we get x equals 3,896. And that's pedals. So if you remember, this X right here belongs right up there, and that's pedals. So if you traveled on that trip, you would have pedaled around on your bicycle 3,896 times. All right, let's try another one. So this one actually deals with scale. So this is what I was referring to when I was discussing that. You know, there's scales on a map. There's scales. I used to do a lot of model building when I was a younger kid in probably late elementary school, in my early teens. And you would when you would buy your modeling kits, they come with the scale included. So it might be a 1/20th scale, which means it's shrunken down to 1/20th of the size of the original whatever you're building. So if you did an airplane scale, if you had an airplane that was 100 feet long, to shrink it down 1/20th, now your scale would be actually um, 5 feet long. So that would be a pretty big one. That would be like a model airplane that you would fly. So, and it's, of course, there's other smaller scales in that too. Okay, so on this one, on a model airplane, the scale is 5 centimeters is equal to 2 meters. So this is our established ratio that we know, right? So it's 5 centimeters to 2 meters. Now we need to set that up to another ratio to form a proportion. It says if the model's wingspan is 28.5 centimeters, what is the actual wingspan? So that 28.5, notice it's centimeters. So we need to put 28.5 centimeters on top. The bottom is going to be meters, but we do not know what that is. That's what we're trying to figure out. Now, in order to solve this, same as all the other ones, we're going to do a cross multiplication. So those two get multiplied, and then those two get multiplied. So when I do 5 times x, I get 5x. And then I do 2 times 28.5, which gives me 57. From there, I'm just going to divide by 5. I get x equals, so 5 will go into 57 11 times. That's 55. 5 times 11 is 55. We're trying to get to 57. So the remainder would be 2, and we put the remainder over what we originally divided by. So in this case, it would be 11 and 2/5 meters. Sorry about that, guys. My light keeps going out in my room. So 11 and 2/5 meters. Or this would actually, since we had decimals in the original problem, you could say 11.4 meters, and that would be fine too. Okay, last one. Another scale models. It says a map of North Carolina, Raleigh, and Asheville are about 8 inches apart. If the scale is 1 inch equals 12 miles, how far apart are the cities? So this is exactly what I was talking about. And if you open up Google Earth or just Google Maps, you can see when you zoom in and out with your fingers, the scale at the bottom right-hand side of the Google Maps will change based on how far you're zoomed in and zoomed out. So we're going to start with our established ratio, which is 1 inch is equal to 12 miles. So we've got 1 inch equals 12 miles. And we're going to set that equal to a proportion. And it says on the map, they are 8 inches apart. So we need to put 8 inches in the same place that inches is in our original ratio, which is 8 inches right here. And you can see then they said, how far apart are the cities? So we do not know how many miles apart they are. So we put an X for that. And cross multiply, right? So 1 times x, and then we're going to do 12 times 8. So when we do 1 times x, we just end up with x, and then 12 times 8 ends up being 96. And so what that means is this x right here, x represents miles. And so what you can see is these two cities are 96 miles apart. So all right, guys, that's all I got for you today. Hopefully that made sense. If you need anything, feel free to email me. Have a great day.